to number 13. So if you had worked on the left side of the equation, you know that you're going to have to subtract these, combine them, because you end up wanting a monomial on the right side. So that's where I would start. So secant is 1 over cosine minus cosine. The only way that I can add those is if I have a common denominator. So I multiply this second term by cosine over cosine. So now I have 1 over cosine minus cosine squared over cosine. I have my common denominator, so I have 1 minus cosine squared x. I subtract the numerators over cosine x. 1 minus cosine squared is sine squared x over cosine x. So now you might be thinking you're not sure where to go. So look at what you are trying to prove. You want to end up with sine times tangent. Well, right now I have a sine squared. I need the sine, so I'm going to take that one out. Now I also need a tangent. So if I take one of the sines out, I'm still left with another sine over the cosine. So that gives me sine times tangent. Okay, so that's number 13. All right, and number 14, I know that we've done ones like this before. I talked about how in this right fraction, we're going to multiply by 1 minus sine theta. So let's get started on that. I'm not doing anything to my first fraction. Now, for the most part, I am not going to distribute that. Always leave it undistributed to start with. Maybe you'll have to distribute it later. You don't in this case, but you never know. So over 1 minus sine squared. All right, I'm still not doing anything to the first fraction. One minus sine squared is cosine squared. So this is why we didn't distribute that, because now my cosine and my cosine squared, I can divide out one of the cosines. By dividing out one of the cosines, this denominator is going to become just a cosine. That's going to be gone. So now I have a common denominator. So I can add these fractions. I have 1 plus sine theta plus 1 minus sine theta. Sine theta minus sine theta gone. 2 over cosine theta equals 2 times secant theta.